is page 47, problem number 8. So we have Arnold holding a mass up against a wall, somehow person like that. And we have an applied force equal to 600 newtons. We have a mass equals something we don't know. We know that the mu static is 0.80. And we are trying to kind of solve to figure out what is the greatest mass that we can apply. First thing with a problem like this, of course, is the force of gravity down. We know that there is an applied force this way. There must be a normal force back. But if the block doesn't move, there must be a force upward. And it's a giveaway that we're given our static frictional coefficient. This is static frictional force, keeping it from sliding down. This is a case where the net force in the y direction equals 0, and the net force in the x direction equals 0. In the y direction, that's equal to the force of static friction minus the force of gravity. And in the x direction, that's equal to the normal force minus the force applied. So that tells us that the applied force is equal to the normal force, which means the normal force is equal to 600 newtons. If we're looking at the y direction, which is the big direction we care about, well, that tells us that the force of static friction equals the force of gravity. The force of static friction, max, which is really what we're looking at here, is equal to mu s times the normal force. That should be equal to mg in our particular problem. The normal force is a known quantity. We're looking for mass, so I'm going to solve this to say mass equals mu s Fn divided by g. And that leaves us with mass is equal to mu s of 0.80 times the normal force, which was 600 newtons, divided by the acceleration due to gravity, which is 10 meters per second squared. And so our mass ends up being 48 kilograms.